Welcome to your online mathematics class, students. So as sequence and series are going on and I have solved difficult questions, so we are continuing with that. Ncert exercise 9.3 and question number 23. So in the previous videos and in the live classes I have solved difficult questions, so I will be solving more difficult questions. Okay, so this is question number 23. It says if the first and the nth term, okay, if the first and the nth term of a GP, okay, of a GP, it is given to us R, A and B respectively, and if P, okay, capital P is the product, or capital P is the product of n terms, prove that P square is equal to AB whole raised to the power n. Okay, so first, students, as it is given in the question, it is GP. So if I write a GP, so how do I write a GP? A, write AR, then AR square, then AR cube. It will continue till nth term, okay, A R raised to the power n. Alright, this is nth term, or you can write AN. Alright, you can write here AN. Okay, AN. So this is your AN. Now another important thing, what is given in the question, that A and B are the first and nth term. Okay, this means AN here. Okay, we know that in a GP, nth term of a GP, AN is equal to ARN minus 1. Right, this is the formula which we are studying and which we are using. So that is why I didn't write directly. Now I will write. This means I can write this GP as A, AR, AR square, AR cube, continue till ARN minus 1. Are you following why I am writing ARN minus 1? Because in this GP, the last term is AN. Okay, obviously when we are taking A, AR square, so the last term will be AN. Alright, and we know that nth term of a GP, okay, nth term of a GP, this is nth term of a GP. We know that nth term of a GP is this, AN is equal to ARN minus 1, and this is also given to us as B. This means B is equal to ARN minus 1. Okay, so there are two different things. I'll tell you. First, understand this. So A, AR square, AR cube, dot, this means continue till ARN minus 1. Now see, it is saying if P is the product, so this means I will write now P is equal to product of this A into AR into AR square into dot ARN minus 1. Right, now how to solve this? Now see here A, so I'll change the ink. See here it is A n times, okay, multiplied n times, so I can write A raised to the power n, right, into R raised to the power 1 plus 2 plus 3 plus 4 plus 5, continue till where, students? N minus 1. Understand this step. See here R will, now it is multiplication, so base is there, power will be added, so R raised to the power 1 plus 2 plus 3 plus 4, continue till n minus 1. Right, I can write this. Now see here on the right side, rough work I am doing it right side, we know that sum of n terms 1 plus 2 plus 3 dot n is equal to n into n plus 1 by 2. We know this, we studied in 10th. Okay, sum of n terms, okay, using AB also you can solve. Sum of n terms is n plus 1. Now if you see carefully here, it is 1 plus 2 plus 3 continue till n minus 1. So I will write here 1 plus 2 plus 3 plus dot continue till n minus 1 is equal to, so in place of n I will replace by n minus 1. So n minus 1 from here, right, n minus 1 plus 1 upon 2. Understand this step carefully, students. I have replaced n by n minus 1, so here it will be now n minus 1 and n minus 1 here, okay, and plus 1. So this minus 1 and plus 1 will be cancelled now. Minus 1 and plus 1 cancelled, so we are left with n into n minus 1 by 2. So I can write the sum of first n minus term will be n into n minus by 2. So I can write here this is equal to A raised to the power n into R raised to the power n minus 1 upon 2. Alright, till here it is clear. This is product P. Now see another thing, it is given that B, nth term, okay, nth term of a GP is given to us as B. So I'm writing here an as, now I will write B is equal to A, okay, B is equal to A r n minus 1. So B upon A is equal to r raised to the power n minus 1. This A in multiplication, here it will be in division. Now if I write B by A, okay, 1 upon n minus 1 is equal to r, I can write this because I am dividing n minus 1 to the power. See here again on the right side, if I write x raised to the power k, x raised to the power k is equal to y, right? So if I have to take x raised to the power 1, this means I have to divide by k. I have divided by k, this is equal to y 1 by k. So what I am doing on left hand side, I have to do on right hand side. So this k and k is cancelled. So x raised to the power 1 is equal to y raised to the power 1 by k. So this is what I have done here. Okay, r raised to the power n minus 1. I have to make r raised to the power 1. So how will I make 1? By dividing n minus 1. Okay, because I need to get the value of r here, substitute here. So dividing by n minus 1. Okay, so r is equal to b upon a raised to the power 1 upon n minus 1. Now this value of r we will substitute in this, okay, in this equation. This value of r substitute here, okay. So I'm substituting here is equal to a raised to the power n into, what is the value of r? B upon a, okay, 1 upon n minus 1 raised to the power n minus 1 by 2. Now see carefully, n minus 1 is here and n minus 1 is here, so I can cancel this. So this n minus 1 and this n minus 1 cancel. So what I'm left with, a n b raised to the b upon a raised to the power n upon 2. So I'm continuing here. Okay, so I'm continuing from here. Alright, so p is equal to a raised to the power n b upon a raised to the power n by 2. Now you see in the question it is saying p square. So now if I take square here, p square, so this is equal to a raised to the power 2n upon b by a raised to the power n by 2 into 2, because I'm taking square, so that is I have to take square here also. So this 2 and 2 cancelled, so I'm left with a raised to the power 2n, okay, b upon a raised to the power n. If I open this bracket again, I will be getting a raised to the power 2n b raised to the power n or a raised to the power n. See, if I remove this bracket, so b raised to the power n, a raised to the power n. So 2n is here and n is here. So when base is same and it is in division, so power will be subtracted. So 2n minus n is equal to n, which is equal to a raised to the power n, b raised to the power n. Okay, so this is your p square. So this means I can write p square is equal to ab whole raised to the power n. Are you following, students? P square is equal to ab, okay, raised to the power n. So this is what we had to prove. So hence proved. Okay, I hope students have followed. So in this way we will complete this. Alright, question number 23, it is important question. So I'm repeating again. See, it is saying if the first and nth term of a GP, so we take a GP ar square, ar cube, dot till an, because it is till nth term we are taking. We also know that nth term of a GP, what is nth term of a GP? ar raised to the power n minus 1. So now I can write this GP as a comma ar square, ar cube, dot continue till ar n minus 1. Okay, nth term of a GP, this is nth term, okay, an is nth term, and we know that nth term is ar n minus 1. So I'm writing ar n minus 1. Now it is saying that p is the product, so p is equal to product I will take of this GP, a into ar square, ar cube, continue till ar n minus 1. Now see, when it is multiplication and it is base, so power will be added, 1 plus 2 plus 3 plus 4 plus 5 plus continue till n. So I am writing a raised to the power n, right, into r raised to the power 1 plus 2 plus 3 plus 4 continue till where? N minus 1. Now see, I explained this. Okay, I had explained this, that sum of n terms. Okay, sum of n terms, we know that sum of n terms is 1 plus 2 plus 3 dot n is equal to n into n plus 1 by 2. but see here it is n minus 1, so here I will replace n by n minus 1. So replacing here n by n minus 1 and replacing n plus n here, and replacing this n here by n minus 1 and this plus 1. So minus 1 and plus will cancel, so I'm left with n into n minus 1 by 2, right? So I can write here this r raised to the power n into n minus 1 by 2. Alright, now we know that a n is equal to a r n minus 1 nth term of a GP, right? And it is given that nth term is b. So this means I can write this as b. So b is equal to a r n minus 1. Now this a will go here on the left side, it will be in division. So b upon a is equal to r n minus 1. Now you have to make this 1, okay, because I have to substitute the value of r here. Okay, if I have to substitute the value of r here, so I need to get the value of r. So if I divide by n minus 1, so I will be getting r raised to the power 1, and here it will be b upon a 1 upon n minus 1. See, I had explained here also with an example. If x raised to the power k is equal to y, so what will be the value of x, not x raised to the power k? This means if I divide by k, if I divide by k, so here it will be 1 upon k. So x is equal to y raised to the power 1 by k. So that is what I have done here. So b upon a 1 upon n minus 1 is equal to r. So this value of r I have substituted here. So b upon a 1 upon n minus 1, and this was in power. Okay, so n minus 1 by 2. So n minus 1 and n minus 1 cancelled. So what I am left with, a raised to the power n, b upon a n by 2. Okay, then continued from here. So p is equal to a raised to the power n, b upon a n by 2, right? If I open this bracket, okay, then I am taking square now, because you have to show that p square. So if I take square here, then I have to take square here also, 2n, and this is into 2. So this 2 and 2 cancel. So what is left? N. So a raised to the power 2n divide into, this is into, okay, b by a raised to the power n, a raised to the power 2n. Now open the bracket, b by n upon a by n. Now see here it is division, students, and base is a, so power will be subtracted. So 2n minus n, okay, simple, it is 2n minus n is equal to n. So that is why this a n has come, okay, and b raised to the power n. So together I can write this as p square is equal to ab raised to the power n. So hence proof. So in this way we will solve this question. Okay, I want to solve more questions, students, so try and solve other questions also. Alright, then I will explain you more questions. So study well. Alright, study well and be disciplined, students. So in the forthcoming videos I will solve more questions and you should try. Okay, study well.